Okay, for number 18, we need to find the mass of 1.36 times 10 to the 22 molecules of HCl. And remember when I told you that anytime the problem has molecules or atoms in it, you have to use Avogadro's number. So we need to use Avogadro's number here. All right, so the first thing we want to do is write our map. What are we looking for? We're looking for grams of HCl. So that's what we want to end up with on top. And we've been given, so we write what we want. Now we write what we've been given, which is 1.36 times 10 to the 22 molecules of HCl. And now I want to do something where I can get rid of molecules of HCl. So molecules of HCl is on top, so I'm going to put molecules of HCl on bottom. And what is going to be my conversion factor is Avogadro's number, because we know that for every mole of anything, in this case of HCl, we have Avogadro's number of molecules. Molecules of HCl. Okay, so now we can cross off molecules of HCl. Boom. All right, so now we have moles of HCl on top, but we need grams. So what can we do to get rid of moles of HCl on top? We know it's going to go on bottom, so let's just go ahead and write it. What do we know that will give us grams of HCl per mole? So we know that it will be the molar mass. Hydrogen, one hydrogen weighs 1.008 grams, and one chlorine weighs 35.45 grams. So I use my calculator on my phone, and that tells me that we are going to have 1.008 plus 35.45 gives us 36.458. So 1 mole of HCl weighs 36.458 grams. Okay, and cross off moles of HCl, and now we have grams of HCl on top, and we need grams of HCl on top. So let's go over to our calculator, and we will do, let's see here, we had 1.36 second EE to the 22 molecules. And what are we multiplying that by? 36.458, okay, times, 36.458. And I did something wrong here, so we're gonna have to clear this. All right, we want 1.36 second EE to the 22nd times, I already forgot it again, 36.458. 36.458 parentheses divided by, and we're going to divide by Avogadro's number, 6.022 second EE to the 23rd. And that's going to get us 0.82336. So 0.82336 grams of HCl. Remember that if what we're looking for, so over here, if this is grams or moles, we're going to have a small number. But if this is atoms or molecules, we're going to have a big number. So since we're looking for grams, we would expect a smaller number. And by small, I mean anywhere from like a decimal to hundreds. You could get hundreds or even thousands of grams. But you're not going to get something that's like 4.58 times 10 to the 30 grams. You won't get something like that, or moles. You're only going to get something this big if you're looking for atoms or molecules. So that's one way to check to make sure that you did it right. All right, so now we want to look at our significant figures. In our original problem, we have 3. So we have 1, 2, 3. And remember, we don't count this in our significant figures. So let's go back to our answer. Let's underline our 3. 1, 2, 3. We'll look at one more. And we get 0.823 grams of HCl. So hopefully we do. We have that option. Pretty close anyway. My rounding could be a little bit different than PK's rounding, but 0.824 is very close to 0.823.